Hello everyone. So maybe let's start about Spring integration. So the objective of today's module is going through the Spring integration, different kind of components of Spring integration architecture, integrating Twitter in a Spring application. I will walk you guys through the code, the configurations. I'll share you the steps. You need to do that part as an assignment. It's a really straightforward job to integrate or to create an Spring application and integrate with the Twitter. Walking through your Twitter applications and course calendar project. So I will give you the overview of course calendar project. Some of the components are already developed there, the code is there, but some of the components you need to develop. Spring integration. We know that, in today's business application rarely live in isolation. So nowadays, in any of the business you talk about, applications rarely live in isolation. We need to have some kind of a mechanism where application 1 can talk to application 2 or application 3 or application 4. So how to do that? If application 1 is created in Java stack, application 2 in Microsoft, application 3 in some, let's say, old technologies or old languages, CS, C Sharp, C++, how we are going to interact with those kind of a application. So in those kind of a scenario, we have middleware, which is independent of technology. Whichever technology you are using, that is independent of it. So nowadays, user expects instant access to all business functions an enterprise can offer, regardless of which system the functionality may reside in. This requires disparate applications to be connected with the larger integrated solutions. And this integration is usually achieved through the use of some form of a middleware. And you can develop or you can create middleware with any of the technologies. There are specified technologies or frameworks which we can use that. We have a different big tools as well. Adobe, IBM, all the big players have their middleware tools. So one of it's TIBCO, different kind of ESBs for different businesses. So middleware provides the plumbing such as data transformation and routing. So these mechanism is provided by middleware so that two disparate application can talk to each other without facing any issue in terms of technologies. Enterprise Integration Pattern, EIP. Enterprise integration patterns are a set of patterns that addresses the common problems that come across in building enterprise applications. Integrated applications are independent programs and each of them can run by itself. Yet these functions coordinate with each other in a loosely coupled way. Messaging enables data or commands to be sent across the network using a send and forget technique. So if you guys have any computer science background, then you must be aware of the send and forget technique, which we used to go through in one of the subject, or I would say one of the chapter in computer science, right? So the same technology or same concept being used here, send and forget. Sender will send a message to the receiver and forget it, and then it start doing something else. So this is the approach which is used by this framework for the transmission of the message across the system. Optionally, the caller can later be notified about the result through a callback, like we have in HTTP as well. What is Spring integration? So how or what Spring is doing here? Let's talk about that first. So what is the help Spring is providing in this area? RabbitMQ, HornetQ, Kafka, ActiveMQ, there are different messaging queues we have. So that is one of the option to create a bus kind of a thing. Another is SOAP, REST. So what Spring is doing, Spring is giving you integration points, or I would say templates API, so that you can connect or you can easily develop your APIs or your codes around these technologies, whether it is ActiveMQ, whether it is HornetQ, Apache Kafka, or SOAP, REST. So Spring provides out-of-the-box templating support for this kind of a framework. So Spring integration is a messaging framework that supports lightweight event-driven interactions within an application. Spring-based applications can be benefited by using Spring integration that supports integration with external systems via declarative adapters. These adapters provide a higher level of abstraction or Spring support for remoting, messaging, and scheduling. You need not to worry about those things. Everything is done by Spring. Spring Integration's primary goal is to provide a simple model for building enterprise integration solutions while maintaining the separation of concerns that is essential for producing maintainable and testable codes. So, like any other things which we have gone so far, like JDBC template, like REST template, like ORM Hibernate template, or MVC dispatcher servlets, filters. So, like these APIs, Spring gives you one handler using which you can build the entire applications without worrying about the underlying things. Similarly, for Spring integration, Spring provides the API for the same, so that you can seamlessly integrate your application, or you can seamlessly create something on REST, SOAP, any kind of a JMS messaging queue, or you can easily integrate with a Twitter, any kind of social media, Facebook, YouTube, LinkedIn. So they provide the APIs so that you can seamlessly integrate or seamlessly call these APIs or functions which resides in some other area. Which language or framework Facebook is built on? Mainly PHP. So Facebook is built on top of mainly on PHP, and gradually they are using some UI technologies, Node.js and all those kind of things, but mainly it's a backend is PHP. So now you think, I mean, you can create a Spring application, your Spring web application, and using Spring integration, you can connect Facebook application. You can post messages, you can get likes, you can read likes, comments. So irrespective of the technology. So this is the strength of Spring integration APIs. It helps us to connect with any of these applications irrespective of the technologies or framework they built on. Spring integration architecture. Spring Integration's core is a messaging framework that supports lightweight event-driven interactions within an application. On top of this core, it provides an adapter-based platform that supports flexible integration of application across the enterprise. Two areas of focus for Spring integration, like lightweight inter-application messaging and flexible inter-application. So where one application is talking to different application, both are maybe running on JVM or some other thing. So the internal architecture of Spring integration API looks like this, with the core developed in the form of messaging. Spring integration adapters, which we're talking about, right? Adapters are used to map the content from outbound messages into the format that some external system expects to receive, and to map inbound content from those external systems into the messages. So it can be like sending messages to some external system, or reading messages from some external systems, maybe Facebook, maybe Twitter or something else, irrespective of the technologies or framework they are built on. So the way mapping is implemented depends on the particular adapter, but Spring integration provides a consistent model that is easy to extend. There are some adapters provided by Spring integrations like RSS feeds, which is very common nowadays in the social media, or e-commerce, really simple syndication feeds. You can have that. Web services, REST or SOAP, Twitter handles, Twitter templates, XMPP, extensible messaging and presence protocol. Using XMPP protocol, you can do that. Then we have a very old technique and very reliable technique, that is JMS, Java Messaging Service. And we have a different MQ series or messaging queues for that, like RabbitMQ, Hornet, Apache Kafka, ActiveMQ. So one of those example will see that again. Then we have remote method invocations and mail. Mail can be on SMTP, POP3 or IMAP protocol. So these are some of the form of adapters which Spring use in the form of Spring integration to communicate with external system. So these supports is provided by Spring Integration API. So let me walk you through the workflow of how message flows and how many components invoked or used in between the flow of the messages from point A to point B. So before that, I would like to show you one PPT which I have created just to have high level view of Spring integration diagram. So this is how it can be bigger depending how big your organization is, but it is something like that. So let's say one of the system, let's say business account systems, which has some functionalities like manage profile, update business, check reports, buy products functionality. which is built on top of Java J2E stack, and it is developed or maintained by some team. Then we have fulfillment systems, which taking care of generating bills, generating invoices, shipping, billing, and payment gateways. So this particular system is built on Microsoft stack, but somehow they are part of one large enterprise, and they need to communicate with each other for some of the operations. Now what to do? In that case, we can use Spring Integration API to let them communicate together. So in case of, let's say, generating billing, there needs to have a product information, let's say fulfillment system, or some customer data, which is maybe residing in business account system. So these kind of back and forth information flow used to happen in between two different systems, and to handle that, we have some messaging APIs which is working with the help of Spring integration in between. So let me show you how the message flow in between. That is, we are going to show with this. Spring integration components. What are the components of Spring integration and how message flows? The very first component of Spring integration is message. The actual entity, the main entity which has all the information. So in Spring integration, a message is a generic wrapper for any Java object combined with metadata used by the framework while handling that object. It consists of a payload and headers. Header can have the informations like to and from address, some metadata, and the payload will hold the actual data which is going to travel over the network. So the payload can be any type, and the headers hold commonly required information such as ID, timestamp, correlation ID, and return addresses. You can also use header to pass some of the values which you would like to use at the receiving end. So developers can also store any arbitrary key value pairs in headers. I mean, for some kind of operations, if you want, you can store that. Like if you remember, if you want to compare this thing with some already known thing, is like dispatcher servlet or your controllers, where the request is coming in the form of, let's say header, and you have some information in request header, some keys, IDs, and all those kind of a thing. Then we have a message channel, another component. The message channel is the thing in which your message flow from one end to another end. A message channel generally represents a pipe or a pipe of pipes, which have pipes and filter architecture. Multiple pipes with filters. Filters is again the same concept which we have seen in security, which is used to do some kind of, or which you use to implement some kind of a business logic. If you want to filter certain information in between the channels, we can use filters. Producers send messages to a channel and consumers receive messages from a channel. The message channel therefore decouples the message components and provides a convenient point for interception and monitoring of messages. So this is how message flows from producer to the consumer, and we can have one or more than one pipes in between the flow. So defining a Spring integration channel, above we have two defined channels which is defined with the help of ID. One is a reply channel, one is a request channel. But here we have not defined what kind of a content can travel through that channel. So in the request channel, if we say data type is util.date, then in that case, only date kind of object will be able to travel through that channel. If you want to pass some other data, let's say JSON, some string, some other object, then you will get a message delivery exceptions because of this restriction, which you have put in your configuration file, that request channel can only support one kind of a data type, and that data type is date. This is also one level of security where we can implement, and where we can say that any specific data type can be traveled through that channel. Some other Spring integration components are message endpoints. Message endpoints' primary role is to connect application code to the messaging framework, and to do so in a non-invasive manner. In other words, the application code should ideally have no awareness of the message objects or the message channels. Below we provide a list of common message endpoints. To better understand message endpoints, a message endpoint is analog to a controller in MVC pattern, which I have told you. So for an example, like any MVC controller or your Spring controller handles HTTP request, these message endpoints handle messages. So like HTTP request travels through your controller, these messages travel through your message endpoints. And if you want to manipulate, process these messages, you need to do that at message endpoints. So what are the message endpoints? The first one is service activator. Service activator is a generic endpoint for connecting a service instance to the messaging system. So if you see here, we have two channels here in front of the screen. One is input channel and one is output channel, and in between we have one service activator. So the input message channel must be configured, and if the service method to be invoked is capable of returning a value, an output message channel may also be provided. So if you see here with the service activator, we have one handler which is handling the message, which is taking the message in the form of input. Then we have a message handler. Handler can process if you want to do some processing of messages. For an example, one of the small example is you want to change the incoming messages to all the incoming message should be in uppercase. So you convert all the incoming messages and execute one function which convert these messages into uppercase. Then you take that input message, convert it, send the output message back to the service activator, and a service activator will take that message back through output channel. So this is one of the endpoints, service activator, which is transforming your messages with the help of message handler. Like this, how to configure a service activator. You have reply channel, request channel, then you have one service activator. In the service activator, like we define services beans in Spring, we can define these activators where you can provide the input channel and output channel and the expression you are going to use. Here again, we can use Spring expression language to do certain business logic like calling the method to uppercase or any other string operations, we can do that. Or if you want to call actual service method, any service method, let's say my service activator dot service IMPL, you can call the method and you can implement a bigger business logic or more complex business logic. So this is how we can configure service activators. Some other message endpoints are transformer and router. As the name implies, transformer is used to transform your incoming messages into something else. For example, a message transformer is responsible for converting a message's content or structure and returning the modified message. Transformer may be used to add, remove, or modify the message's header values. Probably the most common type of transformer is that converting the payload of the message from one format to another, like XML to string, string to JSON, or JSON to object, or object to the JSON. So these kind of a conversion you can do with the help of transformer, which can transform your incoming messages. Then we have a router, which simply route your messages. A message router is responsible for deciding what channel or channels should receive the message next. Typically, the decision is based upon the message's content and or metadata available in the message header. For an example, you have one application created and the job of that application is to generate bulk output. A message router is responsible for deciding what channel or channels should receive the message next, typically the decision making. For an example, you have created an application. Let's say that is Spring Batch. That Spring Batch application is a backend job which takes input in the form of XML, which reads XML files in the bulk, read it, transform it, process it, apply some business logic with the help of some application or something, and then send the messages. Let's say that batch or job is for publication industries, and those XMLs are some books, maybe subject book, computer science, maths, physics, chemistry, maybe books on some writers, drama or something else, thriller, or some religious books. So books can be any type of thing. So the job of that Spring Batch or job application is to crunch the XML and convert those XML into the objects, and that single object represent one single book. Let's say you have a list of books. Now you have a different output channels or output stream application. So for an example, you have a different vendors. Vendor one is saying that I need only subject related books. K-12 books, let's say school books from kindergarten to 10 plus 2. Vendor 2 is saying I need only religious books. Vendor 3 is saying I need only normal book like fiction, drama, and these kind of things. So what you can do, your Spring batch or job application will send the objects through this bus, and the message router job is to route the messages or these book objects on the basis of some tokens. So each book is traveling with the token, and token represents that token 1 is for book type 1, token 2 is book type 2, and token 3 is book type 3. So like that, using message router, you can route this message to different channels, and these different channels will go to different applications. Maybe application 1 which is built on PHP, application 2 on Microsoft or something like that, and they are just consuming those books. So these are some points where we use routers. And another one is channel adapter. So channel adapter is completely built on adapter design pattern. And you know why we use adapter design pattern. If we need to bifurcate the request on the basis of certain business logic, let's say for an example, upload image. Upload image is one functionality in your application. And then you have one adapter for it. Why? Because upload image can have different functionality. You can upload profile image, you can upload logo image, you can upload DP, you can upload some other image. So they have different image functionalities or image types to upload it. So adapter is the point where you can bifurcate the request. You can choose that if the image is coming, the request is for the profile, then call the profile service, update profile, update image profile service. If the request is for logo, then call update logo image service. So the same way we have adapters in messages, just to bifurcate the request depending on some business requirement. So channel adapter is an endpoint that connects a message channel to some other system or transport. Channel adapters may be either inbound or outbound. If you are sending it, then you can connect with the inbound. So an inbound channel adapter endpoints connects to a source system, to a message channel, whereas outbound channel adapters endpoints connects a message channel to a target system. So outbound means I am source, I need outbound. If the destination is you, you may need inbound to connect with me. So this is the job of channel adapter, to connect two different channels. Messaging gateway exists to hide the messaging API provided by integrations. It allows your application's business logic to be completely unaware of the Spring Integration API, and using a generic gateway, your code interacts instead with a simple interface only. So Spring Integration provides the gateways that generates a proxy for any interface and allows you to configure such an interface as a service. So whatever we have discussed so far, so just to let you guys know the functionality, the flow, how the flow works behind the scene. JMS is one of the most complex thing in J2EE. But with the help of Spring integration, when I will show you the example here, then you will see that we are not doing much. As a developer, we don't need to do much coding or configurations. Most of the painful thing which we needs to handle is abstracted by Spring API. So it's like one XML file configuration and some piece of code. That's it. And you can easily integrate with any of the messaging queue. So let me show you before we move to this. So there is a one project I'm going to use, which is a part of your LMS, ActiveMQ for this. So we have one project which send the messages, another project will listen the messages or read the messages. So for this, I am using Spring integration and Apache ActiveMQ messaging queue. So let's start with the POM file first to check the dependencies. So if you see here, apart from having all the Spring beans, Spring jars, I have one integration API, Spring JMS. I am using Spring integration API, Spring JMS, because as an adapter or as an handler, I am going to use JMS. If I would have to use REST or SOAP, then I would have to use another jar which is used for this kind of integration. So since I am going to use JMS, I am using Spring JMS. Apart from that, I am going to use ActiveMQ. So for ActiveMQ, I have ActiveMQ all jar, and rest all are dependent jars. Now, it's a very straightforward example. We have one configuration file. So when you need to create a configuration file in JMS, how to create a configuration file of JMS? You just simply click this, say in Spring Bean configuration file like any other file. Let's say jms.xml and say next. Go and select the bean, choose the bean, say next, say finish. In that, go to the namespace, select JMS part here. Okay, because we are going for the JMS integration. So once you have JMS integration, you have JMS beans here, and you can keep adding listeners for your JMS. Similarly, we have used JMS here as well in this configuration file, jms config.xml. Now what we are doing here, we are defining some beans as in Spring beans. First thing first, if we need to use some handlers like these things, so these are some adapters, Spring integration adapters, RSS, SOAP, Twitter, REST, XMPP, JMS, RMI. So whenever we have any of these adapters, we need the adapter informations. So for an example, if you have web services, then you need the targeted location where your web services are deployed, how you are going to read that web service, right? So you know when we consumed web services, it's must, whether it is SOAP or it is REST, we need to have a WSDL or one URL to connect through that service, right? So similarly, we have one IP host information, host and port information for all these adapters. Even it is RSS, Twitter, web services, XMPP, JMS, RMI, we need to have some remote location for these adapters. Similarly, we are going to use JMS, and if we are going to use JMS messaging queue, we need to have the destination where we are going to send the messages. So the first step to send the message, if we are sending the message, to whom we are sending the messages. So the first thing, information about your address, that is destination. So the destination here is, I am going to use ActiveMQ. So I am using ActiveMQ class here. This class is the destination. If you are going to use Hornet queue, if you are going to use Apache Kafka or any other messaging queue, you must be knowing that there is a class in that API which is going to be act as a destination. So we use that as a destination. So here the ActiveMQ is part of your ActiveMQ jar, and in this we pass one constructor argument test.q1. So this will be the name of the queue where we send the message or where we save the messages. So they have different queues. You can name the queue. If you name the queue, you can access the queue with that name. So the queue which we are going to use in ActiveMQ name is test.q1. Now I have a bean in the form of destination, and in that we have one queue name to which we are going to post the message. Next step is to create a connection, like we need to create a connection with the database, like we need to create the connection with some other repositories, maybe big data repositories. We need to have a URL, some kind of a host or port name. Similarly, for connecting through ActiveMQ, we have to provide TCP location, localhost and the port, host name, port name, and how we are going to connect through TCP. Now we have connections ready to talk to messaging queue. Now comes the Spring integration API. This is the Spring Integration API, JMS template. Remember, like we have JDBC template. In the JMS template, this is part of Spring JMS jar. JMS template, JDBC template, REST template, SOAP template, or whatnot, Hibernate template. So Spring provides different classes for different functionality to be implemented. So for JMS integration, we have JMS template, which takes the parameter of connection factory and the destination. Now I have a producer template to send the message. Using this template, we can send any message to this queue. So now I have a template, and you can treat this class as a DAO class. Let's say we inject template, JDBC templates or DAO or data sources into the DAO layer. We inject Hibernate template, JDBC template or those kind of things into DAO layer. And sometimes we use XML configurations and sometimes we use annotations. So we are injecting producer template into this class, and here in this we are sending messages using JMS template. How we are doing it? We are creating a message through message creator class, which is again part of Spring JMS. We are creating the message, which is nothing but one single string. You can send some other messages as well or a JSON as well, but this time we are sending string. To run this producer class, we have one utility, which is JMS producer, which simply load the XML file which we used to do earlier in the class 1-2, like loading application context file and sending the messages. So we load this configuration file, and then using message producer, we send 5 messages in a row. I have the configuration ready here. I have the class ready here to send my messages. 5 messages I am going to send. I am sending a data to something, right? That is ActiveMQ, and we are using some protocols. Protocol, host name and port name. It should be up, right? Somewhere we need to make sure that service is started. So we are going to use Apache ActiveMQ 5.9.1. I mean, that is one of the server. ActiveMQ is not the part of it, but just for your information, these are some configuration file. If you want to open some of these configuration files, you can read. There are many other things here in ActiveMQ. Itself a big thing, not a small one. So if you open these things, you will see different receivers, transport connectors. If you see, these are connectors. So this TCP we are going to use, TCP 61616. We have something else as well, AMQ, Stomp, MQTT, web services for SOAP. So we have these different connectors here. So for this time, we are going to use TCP. So let's run this server. So if you see here, the server is running now. At the end of my screen, if you see, there is one URL mentioned, localhost 8161. This is the port on which ActiveMQ running now. So let's open it, 8161. So it's open. If you click on manage ActiveMQ broker, it will ask for username, password. It is admin. You will see multiple options: queues, topics, subscribers, connections, networks, send and all. So we are going to send messages to queues. Let's go inside the queues. This is the queue, and the queue name is test.q1. This is the name we have used in configuration file. Now if you see here, everything is empty here. Number of pending messages, number of consumers, messages in-queued, messages dequeued. So what I am going to do, I am going to run this application, this class, and it will send 5 messages. If you see this loop, for loop, sending 5 messages. So 5 messages send. So if you refresh this, you will see 5 messages. Number of pending messages are 5. Messages in-queued 5. Now 5 messages are there. So someone has to read it. The messages which is sent by sender. So let's look into the listener. I have a listener. POM is configuration is same. Let's see the XML configurations for queue. First 2 part is same because it also needs the same 2 beans to connect into. If you are sending a message, you need a connector. If you are receiving or reading a message, you need a connector. So you need these connectors. Then you need another listener class, which is again a part of Spring API, Spring JMS. that is Spring JMS listener, default message listener container. In this, you need to pass connection factory, destination, and your listener class, which is going to listen the message. Now, when you open the listener class, you will see there is method here which implements message listener. Message listener is again an interface part of ActiveMQ. You need to implement and override this on message. And this message you need to read, which is again part of ActiveMQ jar. So using this message, you can read the message simply message.getText. So now when I start reading the message here, you will see the change here. So far number of pending messages 5 and can include 5. Let's listen the message or read the message here. So listener started, one by one it is reading the message or receiving the message. So when you refresh this page, you will see the situation is changed here now. Number of pending messages becomes 0 because the messages are gone. Someone has already read it. Number of consumers who consume the messages 1. Include messages was 5 and dequeued messages 5. So now if you see here, Spring abstracted each and everything here from you. So it makes the life of developer much more easier, because maybe 8 years back when we need to write JMS based application, we need to write hell lot of code to send a message, to receive a message, and to configure it and whatnot. Spring social integration. So what is new here? So what you have seen previously, so far you have seen the integration provided by Spring for anything. I mean, whether it is a social media, whether it is a JMS, whether it is web services or SOAP, REST, databases, big data repositories, ORMs, it provides you the API, the handlers like template classes. Similarly, in the case of social integration, it is doing the same thing. So with Spring social integration, your application can play the part of the service consumer. So your application will become consumer and you consume the services from Facebook, Twitter, LinkedIn, GitHub, or any other. There is a connect framework that handles the core authorization and connection flow with service providers. And that framework resides inside Spring social integration APIs. Then we have a connect controller that handles the OAuth exchange between a service provider, consumer, and user in a web application environment. So in a very layman terms, OAuth is something which is like logging or accessing any application or website without the use of username and password. How it is happening, I'll show you in another slides. So OAuth is the way where you can connect to Facebook, LinkedIn, Twitter, or GitHub without using the username and password in your application. How we do that, I'll show you. Then we have a sign-in controller that allows user to authenticate with your application by signing in with their provider accounts, such as their Twitter or Facebook, LinkedIn, YouTube, or any other social media accounts. So these are some templates provided by Spring using which you can authenticate using OAuth and integrate your application with these biggies: Facebook, Twitter, LinkedIn, GitHub, YouTube, and whatnot. So let's see one of the example. Let's walk through the example with Twitter, and as an assignment I would ask you guys to do that. Most of the code you will find here in your slides. Spring integration with Twitter. Spring integration provides support for interacting with Twitter. With the Twitter adapters, you can both receive messages and send messages on Twitter. You can also perform a Twitter search based on a schedule and publish the search results within messages. Since version 4.0, a search outbound gateway is provided to perform dynamic searches. Let's see that. What are the first steps we need to do to integrate with Twitter? If you want your application to connect to Twitter, you must create a new application on the Twitter developers site. That is Twitter's developer site. So what is that? Let me show you. Most of the time, you guys will see all these giants will have their developer site, Twitter's developer. So there is one Twitter site, then you can see there is Twitter developer site. Similarly, we have Facebook and other developer sites. like this, Facebook developer site. So you need to log in here, you need to create your account here, and you have that account in use for interacting. So first of all, you need to log in to this dev.twitter.com or Facebook dev.twitter.com. So there is a developer site for Facebook. Now you need authentication keys so that Twitter can verify your applications. Once you log in to your Twitter developer site, you need authentication keys so that Twitter can verify your applications. Following are the steps we need to follow to have those keys. First of all, you need to log in to Twitter sites, register your application with Twitter. Default Twitter restrict application to read-only permission, so you have to change it. Get the access token keys for your application like this. This is the page you will see. Here you have to write your application details, name, description, website, and callback URL if you have. Then you need to change the permissions, application permissions. Usually once you logged in first time, it is read only. So you can modify your application settings by clicking on modify app permissions. So it will take you another page, something like this. Here you need to change the permissions from read only to read, write, and access direct messages, and you then update the setting. So this way you will have the permissions to read the messages, write the messages, and access any messages from Twitter directly through your application. Now the next step is to creating the tokens. There is a window, a tab in Twitter's developer site where you can log in and you can generate a tokens. So click on keys and access tokens tab to generate tokens. So once you click create my access token tab here, it will generate alphanumeric keys and tokens for you. Consumer key and consumer secret, then access token and access token secret. These 4 keys or values you need to access your Twitter account without using username and password. Rather than using username and password, you need to log in to these sites, whether it is Twitter, Facebook, or any other site. You need to create your applications, change your settings, generate keys and tokens. And these 4 values, consumer keys, consumer secret keys, access token and access token secret, you need these 4 values which is going to be used in your application so that you can interact with your Twitter application. Now it will be not a big application. The code which you need to write will be very small. For your web application, you just need some configurations and properties and one template class for your Spring Twitter application. If you see here, we have 2 classes, Spring Twitter template, that is a template class, and then one utility class, Twitter tweet test. It will send the tweets. Then we have properties and XML configuration. That's it. Then we have a configuration with the help of annotation configurations. You can use that. Then you say Spring Twitter template. You can name whatever you want, and you can directly read your properties file where key values using annotation value here, access token secret, consumer secret, consumer key. So it will pick from properties file the value. Then you need to create a bean Twitter template by providing or passing these 4 values to the Twitter template class. This Twitter template class is part of your Spring API like JDBC template, Hibernate template, or any other template we have seen so far. So this is the way. Either you can use configuration like this, or you can use XML configuration like this, and you can use this ID to interact with your application. You can tweet, you can send messages, you can read messages on Twitter account. This is properties file where you can have your keys and secrets keys, consumer keys and consumer secrets, which is generated on Twitter's developer site, or even if you want to use, you can use Facebook, YouTube, or any other. So they have the same kind of a mechanism. They have OAuth mechanism which we can use in Spring. There is a question from Annie. Spring integration offers Twitter blank adapter to send tweets to Twitter. Which adapter? What kind of adapter we use in Twitter? It's outbound because Spring integration is a consumer. Source is Twitter, right? Or Facebook. That is outbound adapter. So this is how your test file looks like, where you can call the bean and simply using generic message, you can create a message and send the message to Twitter. Now, which authentication protocol Twitter uses to approve an application so that it can work on their behalf without sharing the password? It's OAuth, without sharing the password. So it's seamless, it's secured, you need not to share the password, and without sharing the password and username, you can simply access the application. Which of the below is not a message endpoint in Spring integration? Transformer, filter, router, accumulator. Remember, I am saying which is below is not a message endpoint. Transformer is a message endpoint? Yes. Filter is? Yes. Router is? Yes. Accumulator is not a message endpoint. Now, another question, can we provide a specific header to a message to meet our requirements? Remember that message header, message payload? We can by using head enricher class, and there are multiple other class and interfaces using which we can provide that. Course calendar project. Let's discuss about the final project you guys need to submit, and I'll walk you through with the requirements. What are the requirements? Here we have, and some of the part is already developed. You can see and access it. The course calendar project will use the below mentioned features of Spring. So when you work on that project, you can use almost all the modules which we have gone through so far, like Spring security, authentication and authorization module, Spring internationalization features, Spring MVC of course, logging with Log4j, Spring framework database support. It's up to you whether you want to decide to use Spring JDBC template or Spring ORM. Then Spring exception handling mechanism. These are the features we are going to use in this project. What are the requirements? Below we mentioned the features that if requires to the users depending upon his credentials. These are the features we need to implement in this project. First requirement is adding, updating, deleting and searching a course in that application. Adding, updating, deleting trainers, uploading resume of trainers, searching through resumes to find the suitable trainer, creation of new course calendar if you have to create a calendar, assignment for the trainers to courses, multiple user roles like simple user, admin, managers and all those kind of access, and using Log4j logging all the incoming requests to the application file. These are the requirements we are going to develop. What should be the use cases for the application? So once users sign in to the application with the right credentials, user can perform below operation. Can add, update, delete course, can add, update, delete trainers, can create new batch for the courses, can create calendar for the specified time, can perform search through courses and trainers. If the user doesn't have the permission to perform above actions, application will deny the user to access these pages. So that is authorization. First level is authentication. Second level is Spring authorization. So we need to create the application which follows roles and permissions concept. Okay, so let me show you the project. This is a course calendar project here. It's already, I guess, I have shared the URL, but maybe let me do this one more time. So in this project, basic POM is already created, structure is already created, SQL file is already created for you, just for helping you guys how to create a table, how to insert data into the table, how to write a queries, just for the information purpose. This is the part of that project. If you go through the configuration files are there. So web.xml, if you open, you will see dispatcher servlet there and all the related XML files uploaded. for Spring Security, for database connectivity, Spring Database, for DAO layer, service context for service layer. So all the configuration files are there and loaded in your XML. Apart from filter is already created for security purpose. Now, if you see here, there are a lot of JSPs are there as well to help you guys. So if you see the DAO context, you will see DAOs are here, database informations are here, security configurations are there for you, service context is also there, aspect packages, some logging aspects Java, just to give you an idea how to create loggers file is there for your help. Some of the controllers are created here already. Some services, one course services, one course DAO and user DAO is created. Log4j properties is part of it, which you can update if you want as per your requirement. So most of the things are there, which will give you ample of help so that you can complete this project. Let me run this and show you what else is there. So once you start this, it's starting. So let's see the project. So if you see here, the login page is already created. You can use the login here, the user you have used so far. So you can log in here, and when you log in, you will see some of the part is already developed. So course, add, update, delete course, trainers, add, update, delete trainers, calendar, you can add or assign courses here, dashboard, visual analysis, monthly and weekly report, and the contact us page. So if you want to add course, you can add course here. Let's say test. So these application, some of the part, some of the module is already developed with the controller service beans already in place, but some of the use cases you need to create yourself. So for example, course is done, you need to work on the trainers part, uploading resume of the trainer part, upload resumes of trainer if you want, searching through the resumes, how to do that, creation of a new course calendar, how to create a new course calendar project. So these are some things, some of the use cases you need to implement here. Some of the part is already there for your help so that you can take a look here. So I am giving you Vistia URL here. In this URL, you can download all the projects. So open that URL, it will have the text file, and that text file will have all the URLs for the project which may help you, and rest of the project which we have gone through today you can find in LMS. So if you open that file, you will see there are multiple URLs in it. One is a Spring Course Calendar project. Thank you.